Let us start today's session. Welcome all of you for today's. This is first live session from my side. On Saturday there were 2 live sessions. Did anyone of you attend the live session on Saturday? So all of you joined for the first time. Okay. That's okay. So we are okay. That's good. No problem. So these sessions will be same. So we are having 3 sessions. 2 on Saturday from 4 to 8, 2 hours each, and 1 on Tuesday from 6 to 8. So from my side, this is the first session. Other 2 TAs will be taking the sessions. They will be conducting the live session on Saturday. Let me first introduce myself. I'll just make the presentation full screen. Yes, so I'm Gagan Meena. I'm currently doing PhD at IIT Bombay in Power System Engineering. And for second time, I'm taking the upgrading sessions for this course. In the last time also, I was a TA for this course. So these sessions are meant for you to solve your problems, whatever doubt you have, you can ask in the sessions. So try to take full advantage of these sessions. These are simply meant for all of you to interact with the TAs and clear your doubts. Let us move further. So this will be the agenda for the live sessions. First we will go through an overview of week 1. And then we will discuss some questions regarding week 1. In between, I will also discuss some relevant topics, depending upon the questions. And finally, we can have your doubts. In between also, if you have any doubt, you can ask. So just to remind you that deadline for assignment 1 is 9th of August. So please submit the assignments on time. And the live session for this, the recording for this live session will be available on this channel. The same will also be available on the portal. Right now that link is not activated. You will see on the leftmost bottom, there will be one link for problem solving session. There you will find all the presentations and link for the YouTube sessions also. So let us start with the week 1 overview. So this is the basic architecture of Indian power system, and these are the different voltage levels in the power system, starting from the generation side, where we have 11.6 or 1221 kV. Then we have to step it up because at high voltage levels, the current is less, and as a result, the losses are also less. I2R losses are less. Because we want to transmit power over a longer distance, we need to increase the voltage level. So there are 2 options. One is HVDC and HVDC. So till HVDC came, most of the transmission was AC, but it was found that HVDC becomes more economical and the power is to be transferred over a very long distance. So above a certain distance, we prefer HVDC. It becomes more economical, and also there are certain other advantages. Then we again step down the voltage at the distribution side. There we have different type of consumers, like first is the sub-transmission customer at 66 or 33 kV, and then we have primary and secondary customers. And so these 4 topics were discussed in the week 1. First one was basic introduction to smart grid, where we discussed different types of definitions. First, smart grid. What is a smart grid? and then what are the components of a smart grid. Then we discuss architecture of smart grid, standards for smart grid, and different technologies and elements required for smart grid system. So these we will see in further slides. So in introduction to smart grid, we studied how the system evolved of grid, an evolution of Indian grid, different regulatory authorities such as Ministry of Power, CEA, CERC, CTU, STU, all these HVDCs. Then what makes a grid smart? So these are the different components of a smart grid. 4 major components that make a grid smart, that make the conventional system different, conventional power system different from a smart grid. So these are the smart infrastructure, communication, management and protection. So if the conventional power system, we add on these 4 components, then the grid will become smart. Then in smart infrastructure, we have smart energy system and smart information system. In energy system, we already know that we have generation, transmission and distribution. And in information system, smart metering, sensors, PMU and information system. Because of these new developments such as wide area monitoring system, islanding detection techniques, phasor measurement unit, protection relays, and all these components, the grid is becoming more and more smart. Gradually, we are trying to add more and more components to make our grid more smart, so that we can increase the reliability, security, efficiency of the conventional power system. In smart metering, there are 2 main components. One is 2 main points, one is AMR and AMI. So can anyone of you tell what is the full form of AMI and AMR? Anyone of you? Correct. So it's correct. So AMI is advanced metering infrastructure and AMR is automated meter reading. So main difference between the two is that one is one-way communication and another one is it supports bi-directional communication. So advanced metering infrastructure is an add-on. We can say it an updated version of AMR. So AMI enables two-way communication with the meter. So meter can communicate with the utility and vice versa. So generally, our consumption data, our load pattern, everything goes to the utility. That happens in AMR, but utility can also give a certain direction. So that is possible if there is a two-way communication. So when load can talk to utility through meter, via meter. It can respond to the price signal received from the utility via the meter. So these things are possible because of advanced metering infrastructure. Then phasor measurement units. These are the different functions of phasor measurement unit. These are becoming very essential, especially for the wide area monitoring system or wide area situational awareness system. Because of this, we are able to get the state of grid. So one of the main function of the PMU is grid state estimation and disturbance localization, fault level monitoring, and providing loss of mains protection and monitoring power quality. So these are the main functions of the phasor measurement unit. So right now we have phasor measurement unit and transmission system. But at distribution system we don't have any phasor measurement unit. But in literature, we have D phasor distribution, D PMUs for distribution system. So in future, you may see PMUs at distribution level also. So distribution level will require, distribution system will require a lot of PMUs. Then the next thing is smart communication. The communication can be two types, wireless and wired. So wired, fiber optic or power line. In wireless is preferred more. Wireless is preferred more because it is cheaper. Installation cost is low and it can be rapid. Rapid deployment is also possible, and we are using wireless communication a lot. Bluetooth, Wi-Fi, all these things that we are using. So we are used to all these things. Then we talked about the architecture of smart grid. There are 7 main components which interact with each other. In conventional power system, we had transmission, we had generation, then transmission, then distribution, and at the end customer is also there. That is vertical.
Excuse me, sir, someone has not muted his mic. Please give direction that all other has to mute the mic.
Let me check. Okay. Sorry for the distance, so please mute yourselves. Only unmute when you have any doubt. Okay, so let us move further then. These are the 7 main entities we were discussing. So in the vertically integrated system, we only have generation, transmission and distribution. And then now we have these market operation and service providers. All these entities came after the deregulation of the power system. Initially everything was managed by only this one entity. One generator, initially when it started power systems, one generator, one company was doing generation, transmission, distribution, everything. But now it's not like that. So now we have distribution, different transmission is, in India transmission is taken care by PGCIL. Mainly, especially the national and regional transmission level systems are maintained by PGCIL. And this, in state also we have state level STU, state transmission utility is there, which maintains the state transmission system. And then in distribution system, we have in each state we have many distribution companies. Similarly, generation also we have several PSUs and other private generation companies also. Then we have market in India. Do you know? Can you name any power exchanges in India which are operating in India? Right now we have 3 power exchanges operating in India. Can you name anyone?
Power Trading Corporation?
That is not a power exchange. So have you heard of PXIL? IEXL. Oh, that is correct. So it is IEX. So one is HPX. I'm not remembering the name of this, but it is Hindustan Power Exchange Limited, I think. So this is the newest. This is the latest edition. This is the newest power exchange in India. So these two are existing. One is Power Exchange of India Limited and Indian Energy Exchange.
Sir, what does this exchange do, sir?
Yeah, so let us, when we move to that market part, I will tell you at that time. Because there also again we will come to trading and all that. So I will just mention again what do they do. So I was talking about So I was talking about market operation is taken care by. Do you know any company which is there is only one company in India which is maintaining the entire operation of power system, which is monitoring everything. Can you name that company?
Grid Controller of India.
Correct. So earlier it was
some power grid subsidiary.
Yeah. So earlier it was POSOCO. Now it has become Grid Controller of India Limited. So this is you can also say in US we call Independent System Operator. So for India, ISO is this Grid Controller of India Limited. And then there can be different service provider, different types of services can be there. We'll see in the next slides. So first is customer domain. So in this we can have different type of home automation. So these are the function of the customer domain. And different types of devices can perform these type of functions. There can be micro generation. This is the new addition because now we can have even on each home we can have a solar PV, a rooftop solar PV. Even there are some small wind turbines are also available nowadays which can be placed on the roof of the house and they can also generate. Now we are in future. Now also we have certain storage in house with rooftop PV. We also have some battery storage systems, but they will further increase in future. And then we also have electric vehicles. So they can also act as battery. Although that is not being done in India, but outside in America and Europe, there are some pilot projects where you would have heard of V2G and G2V, right? So this is grid to vehicle where the EV is charging. And then it's vehicle to grid where EV is discharging. So it can discharge into the grid, it can feed power into the grid or it can act as a backup. Just as we have inverter at home. So the electric vehicle can also act as a backup to provide electricity power during power cuts, during any kind of fault. Then after the customer domain, we have market domain. So here I will tell that about the power exchanges. So power exchanges, we can say mainly market operations, and so this market operation is taken care by power exchanges. And in power exchanges, we have this trading. So trading, what is being traded in power exchanges? So there are different types of products which are energy products. We can sell or buy. So generators will sell because they are generating. They have power, they can sell. So they will bid. So they will provide their sell offers and the demands or the loads. They will provide buy bids. So the power exchanges will have these generators and loads registered at their site. They provide at a single platform where both the generator and demands, not other entity also can participate. They may not be even generating, they may not be even consuming, but there may be some middle entity which can buy the power and sell it to demand, any load. So such entities are also.
Please tell any name, sir, any famous name
for that intermediary.
Yeah, who can buy and who can sell without generation and without any load?
Yeah, I'm not getting that name. It's a very famous company. JP Morgan. It's a bank, but they also participate in power exchanges. So they will buy from the market and then they will sell it to the consumers, bulk consumers, which are maybe discounts. These are big consumers or discounts.
JP Morgan.
Yes, JP Morgan. That is one example. There are other examples also. So one can be this DER aggregator. So this DER aggregator can directly go to market. So these are aggregator which they aggregate different types of demand. Suppose we have several EVs. In a big parking lot we have thousands of EVs, electric vehicles. Or in a locality there are several homes are there. Their entire load, all the EVs in that area can be aggregated by this DER aggregator. And they can use the energy stored in the battery of this electric vehicle when there is a peak requirement from the grid side. But they will have some contract with these electric vehicles or loads. They will have some terms and conditions. If electric vehicle is there, they will have condition that the state of charge of the battery should not go below certain point. Because suppose you
Sir,
have...
what is DER? Sir, please expand the term because we are new. Expand the terms also. What is DER?
It's distributed energy resource.
So typically for aggregator, for example, for which utility the meter would be same, is it so? So they will have the combined load and there will be a single meter along for the utility, and then internally they will have different mechanism. Is it so? That's how it works.
Single meter for DER, you're saying?
For aggregation. So typically when the aggregation happens, the aggregators, who are the entities that can do this? Is it a separate entity?
Yes, it is
or
a separate
which company? Which company can?
Right now we don't have these aggregators, but these are separate entities.
Achha. So it's not there in India currently?
No, right now we don't. Even
so you have to register them under separate, some specific energy, something like that,
yes,
right?
they are separate
Legal.
companies. They are one of, you can say, one kind of service they are providing.
Okay.
They are also making money out of it. So their main aim is to, because one electric vehicle, there are two purposes. One is that they are providing one type of services, so they will be benefiting from it. Second, they are also helping the grid, because one individual electric vehicle, it cannot provide much energy or peak load. It cannot contribute much to peak load. But
there will be so many customer accounts also to handle and process and everything.
Correct. So if there are suppose 10,000 electric vehicles and they are even providing, if suppose 100 watt, so it becomes 1 lakh. It becomes 1 megawatt. So that kind of services, so that 1 megawatt can certainly affect the peak load of that distribution company.
Yeah.
So in that way it can help.
Yeah. Okay. Thank you.
So it is just a concept right now, but in future we will see all these things. Surely we will see these things. Then, so trading, power exchanges is done, market operation. Trading happens in these power exchanges. Then we have this market management is done by ISO, which is Grid Controller of India Limited in India. So they will always oversee these market power exchanges. So whatever these power exchanges they will do, behind they will run some optimization. Suppose different generators are there, G1, G2, G3, and then we have different demands also. So all of these three will offer they will provide their offer, they will provide their bid. So one common market price will be determined. Let's say 5 rupees per kilowatt hour. So this 5 rupees will be given to all generators and all demands will pay 5 rupees. So this price is determined the market operate these power exchanges. Then how much this generator, suppose this was willing to provide 100 megawatt, this was willing to provide 200, this was willing to provide 500 megawatt. And similarly, these three demands were also, this is how much, 800. So these were providing only, they wanted 700 megawatt. So now we have, market will be cleared for 700 megawatt, 100 megawatt is less. So this generator will only give 400 megawatt. So now that we know that these generator will provide this much and demand will consume this much. So this data will be entered into the network. And then this ISO, Grid Control of India, will check if this much generator at these different locations are pushing power into the network, injecting power, and demands are drawing power, what is happening to the network? Is network getting congested? Is network working fine? If it is working fine, then the market will be cleared. If it is not working fine, then the grid controller will tell the power exchange that whatever price you have discovered and whatever generation you have allotted to different generators, it is not acceptable to the network. They will again modify something. So they will reduce generation. Yes.
My question is,
Yes.
this is very, very dynamic. Very investors, keep on changing their generation as per the demand. So now but the rate is already fixed. Suppose 5 rupees a unit, it is not changing. Now my question is, who is calculating and who is giving these directions to the generators, or whether these 5 rupees unit is also variable in case of peak demand?
Okay. So your question is good. So what happens, this market is, there are different types of markets. One is day ahead market, that is cleared one day before. Suppose for tomorrow 5 p.m. I will have to bid today. So day ahead market opens 24 hours before. You have to give your bids and offer one day before. The window will close and the power exchange will calculate the market. It will do the market clearing. And then so this 24-hour entire process which I have explained to you, it takes time. So there are some timelines according which this happens. So that is why it takes time. Then another market is real-time market, which happens for, in India, we have market clearing for every 15 minutes. So we have 15-minute blocks. 24 hours are divided into 15 minutes. So 96 blocks are there. So for each block, there is market clearing, both in day-ahead market and real-time market. So real-time market will be for next 15 minutes. So this market will be cleared for the next 15 minutes. Right now it's 6:30. So this market will be clear for 6:45. So from 6:45 to 7, the generator will have to maintain whatever it is being asked to maintain. And little bit variations are there that are taken care by reserves or ancillary services are there. There are other mechanisms to take care of these. If they go a lot beyond their scheduled, then they are penalized. Even the demands are penalized, the generation will also be penalized. So this thing continuously keep on.
But my question is, every state has a different, unit state. Somebody has 5 rupees, somebody has 7 rupees. Now, if we say our grid is one, India is one grid. So now it should not then happen, different states have different metering, rate is different.
Tariff is determined, it's not just because of this, because state, they have their own generators also. They have their own transmission network also. And they also are purchasing from market. So whenever the DISCOM is doing something, it is charging. So it has to recover several costs. So it also depends upon different states.
And for the private sectors, I think there is the private PPAs, power purchase agreements that happened, and there they define also what can be the range for the purchasing and selling power.
PPA
So
is
that yeah.
different. So
Okay.
it is between two parties. Suppose I am a generator and there is
Okay.
another load. So it's a bilateral agreement between two.
But then, does that happen with also the utility?
Utility means to say.
I mean, for example, whether the market is open for private generators. That's what I'm.
Yes,
trying to say.
anyone can participate. Even
Okay.
not only just NTPC, NHPC, even Reliance, Adani, they have their generators. They also participate. Even Tata Power has Tata Distribution. They have their distribution companies also. In Delhi, Tata is operating. In Mumbai, Adani and Reliance is operating. So they also participate. They are also discoms. So they also participate in these markets. So anyone can participate.
Okay, in that case, whatever Mr. Anupamji was asking, how do we keep track for the prices? How do we ensure that it doesn't go beyond certain range?
Yes, there is right now there is a market cap of rupees 12 per kilowatt hour.
Okay.
Beyond that, no one can ask. They will not be even allowed. It is capped.
And that cap is defined by?
It is defined by Grid Controller of India Limited. And these policies are developed by these other agencies, CEA. They will make some recommendation to them.
Okay. Alright.
So let us move further. Then this is architecture. This service provider. There are different types of services: billing, and customer management, home management. In home management, there are several services. Home motivation services are there. So these service provider can provide different types of software services for different type of entities, even for generator, for consumer, for anyone. Then is operation domain. So this operation domain is maintained by Grid Controller of India for India. So it will be doing all these functions. So many things are being performed by POSOCO or Grid Controller of India Limited. They are continuously monitoring the entire grid. So everything they have to ensure that frequency remain within a tight band of 49.5 to 50.5, whatever the band is set. And voltage are also limited. So they have to check, is there any condition of blackout or anything happening? Are the generators maintaining their set points? So all these things are checked. Always check. They keep on checking all these things. So for this, there is a wide area monitoring system. They are able to see everything in their control center because of that wide area monitoring system. For that, PMU are required. So PMUs, they send the data to these using this through this to control centers. Earlier we were using SCADA. Now we are using PMU based VAMs. So these are GPS synchronized. So whatever data we were getting from SCADA, they did not have timestamp. But whatever data PMU provides, each and every data has a timestamp that this reading was measured, taken at a particular time instant. So we also know when that reading was taken, measurement was done. But in SCADA we don't know that. So that's why it becomes very difficult to analyze things, to know what is happening at what instant. But PMU helps us to do that. So all these things are possible because of all these smart instruments, equipments. So this operation is a very important domain. Entire grid is being monitored. Smooth functioning of the grid has to be maintained, monitored by this In Grid Control of India Limited, it is also our National Load Dispatch Center. Then we have 5 regions in India, so we have 5 regional load dispatch center also. So we have Western, Southern, Northern, Eastern and Northeastern. And then under each region we have several states, and each state has their own state load dispatch centers. So at each state level they will be monitored. So for all over, for entire country, NLDC will be monitoring. So so they have to keep track of everything. The generators are also obeying, distribution companies are also obeying their schedule, demand. Everything is under control. They have to check all these things. Then we have bulk generation. They do their asset management. They measure whatever is being done, and they have to protect their generator system also. Then transmission and distribution. We have substation, measurement control, and they also store data. Then in distribution we have new entity, which is the distributed generation. We have PV, we have wind. There are micro turbines also. In India we don't have, but they are also being used. Different types of storages are also available. Then we discuss the standards for smart grid. We discuss why do we need standard, benefits of interoperability, and then different types of standard development organization. Can you name any 2 standard development organization? The most widely is their acceptable organization. We have 2 main, especially for electrical.
IEEE and IEC, sir.
Correct. So what is the full form of IEEE?
Institute of Electrical and Electronics Engineers.
Correct. And IEC?
International Electrochemical I'm not remembering the electrochemical.
You can see
union.
on the screen I have written. Can you see? International Electrotechnical Commission. So these are the main standard development organizations. Most of the standards that we follow are from IEC. Also follow some of the IEEE standards also. There are other organizations also. Then in this we also discuss this standards for all these things, all these 5 areas. Then last class was on this elements and technologies of smart grid system. There we discuss advanced metering infrastructure, networking for AMI, smart meters and distributed automation system. So now this was a quick overview. Now I have in the lectures some things are not updated, so I have just updated few things. One of them is starting with this HVDC. So we have HVDC lines of plus minus 500 kV and 800 kV. So recently we have also added this 800 kV line. And also recently we have added this IGBT based HVDC system. The Pugalur Thrissur is the India's first VSC based HVDC system. Before that we were all its predecessors were thyristor based SVC. So we have 4 back-to-back HVDC, and then these are the different bipolar and monopolar. So these are the 800 kV lines. Vishwanath, Agra, Champa, Kurukshetra and Raigad, Pugalur. These green ones are the 500 kV lines. We are using all these, especially for the long distance transmission. And also the one more advantage that
Excuse me, sir. Hello.
Yes.
Excuse me. Sir, please tell us about this. What is back-to-back 2 point and all this? Because I'm seeing this first time, sir.
Actually, this was not mentioned in the lecture, so I was thinking to skip it. Okay, I will tell you, no problem. So, first of all, let me just complete that. One of the main why the first important reason why we went for HVDC is that it is economical to transfer bulk power over long distance, very long distance. Beyond a certain point, HVAC, that we have EHVAC, extra high voltage line AC, beyond a certain point it is not economical. So beyond that distance we go for HVDC. Second, another benefit that HVDC provides is that we can connect two systems which are operating at different frequency. Because HVDC, there is no frequency term, right? It's a zero frequency. It's DC. There is no frequency. So we are able to connect two areas of different frequency. That's how we also have now one nation, one grid, one frequency. Frequency is almost same throughout the country. So back to back is that I think one thing is clear, all of you would be knowing that in this HVDC, one side we have the rectifier and another side we have inverter. Is this clear? Do you know this? Because this is entire DC system. Both side we have AC. So suppose this is AC here. We have to convert this AC into DC because in between it's DC. Again here DC to AC, again AC on this side. So this is rectifier and this is inverter converting DC into AC. So when this entire block, this rectifier inverter block is present inside one substation, this is back to back.
But sir, power can flow in both directions, so it should have both combination, na?
Both combinations
means if it is moving from 1 to second, then it is okay, DC to AC, then again DC. Yeah. Now if it other way,
that is correct. So if this, suppose I will call this one first and second. So if first is acting as rectifier, then second will act as inverter. If second is acting as rectifier, then first will act as inverter. So at a time they will act as one of them, but they can perform, both of them can perform the role of rectifier as well as inverter. So because of bidirection power is required, so both can do both functions, but at a time they will do only one function. So this entire block, if it is present inside one substation, then it is a back-to-back converter, back-to-back HVDC. But in between, if we have a long line, HVDC line, then it is this point to point. Is it clear?
So back to back is typically used to connect two lines. Is that so?
Connect two. We can say.
I haven't understood. So you in the diagram there is back to back also, and it also mentions point to point. For example, if you say Chandrapur in the middle, it also shows both, right?
No, Chandrapur is
point to point.
Point to point. It is from Padhy to Chandrapur. It's a point to point. 4 is this. Chandrapur. Correct.
But it is also back to back.
Is also there.
So how
yes.
How it works? Then it is both. It is mentioned.
So there are both. Point to point is also there, and back to back is also there in Chandrapur. So this we can say back to back is specially we have added for ensuring that connection of two regions. Because one region, we know that one advantage of HVDC is we can connect two regions of different frequency.
Different frequencies.
Yes. So to ensure that back to back is used. So it connects this southern region with this western region.
Okay.
So you can see this is west, south. Similarly, this southern and eastern region are connected using this back to back. 6. This Kajuvaka. And again we have here which connects west and east. And then north and east.
So basically different zones are connected through back to back, and within the zones most of them are point to point.
Correct, we can say.
Yeah.
Because we say that first is long distance transmission, but back to back there is no long distance transmission. It is within the same substation itself. So we are not transmitting any power in back to back. So it is for interconnection of two regions.
It's just conversion. Yeah.
Yes. So it will help us to connect regions of two different frequencies. So,
Thank you.
So shall we move ahead?
Please not
Your voice is not clear. Can you speak again?
What is the difference? Main difference.
Sorry, can you repeat? I could not hear.
So bipolar and monopolar.
Actually,
The main difference. Why we do monopolar?
Monopolar is easy. It's simple. Bipolar is better than monopolar because bipolar has so monopolar is like there is only one conductor, and this return path is the ground provides the return path, and there is only one conductor. But in bipolar there will be two, one positive, one negative.
So in monopolar it is positive only or negative?
Generally we take negative because of there is if we take negative then corona discharge is less. That is why we go for negative. Interference is also less. That is why negative polarity is preferred. But in bipolar both positive and negative polarity is there, and if one of them, suppose one of the line there is a fault in negative or positive, still we can supply half of the power, ground will be used as a return path. So bipolar is more reliable. But initially when we started with monopolar. It was easy to implement. That is.
Suppose in bipolar it's supposed to go. Then the ground is also what is the negative? It acts as negative.
Yes.
And now if negative vector goes bad, then ground will be positive.
It will act as opposite. Return.
But
yes.
then it is not gelling up because it will ground will always be less current.
Ground means it is just simply acting as a return path.
This concept of grounding in terms of what you say transmission is not clear to me at all.
So Actually, ground is simply acting as a return path. Ground is not having any polarity.
But sir, the point is how that entire kilometers of chance we will ensure the connectivity, because inside the ground there is no conductor. For return path, at least conductivity or continuity is required. But there may be some rocky places where the conductivity is zero. So how does that physical, circuit is happening? Can you explain that?
I will have to check this point. Can I tell you in the next class?
Yes, sir. Yes, sir.
Sir, can I have a comment?
Yes, sure.
Sir, how AC generator gets its earthing means? See, generator is provided grounded at generating station in AC system.
Yes.
At the same time, my home is also having earthing system. My distribution transformer is also earthing system.
Correct.
So every earthing is a common. Similarly, it is in HVDC.
Correct. So flow of power will happen when there is.
See, there can be Roorkee in between, but earth can get anywhere connectivity from source to destination.
No, this is not so simple. Okay, if you take your home earth, that is one earth. To say penicillin will inside and protect your equipment. But
No, sir. What is your neutral? What is your neutral? Neutral is earth at a distribution transformer.
No, here my point is you have to complete the circuit also, na? That
But sir, when that I am asking, sir, you when I have a 600 megawatt generator, how it is getting return power? 600 megawatt it is returned to the generator. It is through ground only.
No.
Ground is a common, sir.
I don't think that's such a huge current and all of it. I'm not.
Sir, it is not active current, sir. It is not active current. Neutral has no power. It does not have a heavy voltage. It is just a return path. If you break it, your phase will not work. So it is a return path. It does not have any energy.
Still that some current will flow or not? See, millivolt, so there might not.
Definitely there will be current, sir. Definitely there will be current, but that will be through earth.
Okay, I will clear this in the next class. I will have to check this. I will again get back to you. Is it fine?
Sir, yes, sir.
Okay. So please just remind me next class. We will again discuss this. So now we will discuss some questions based upon for the week 1. So first is this. It's a very simple question. We'll start with a very simple question. So who is father of AC distribution system?
A, sir, A.
Tesla.
Correct. So what about DC?
Edison.
Yeah, so there was this famous current war of currents. So even this Edison went on to electrocute an elephant just to show that this is dangerous. There was a lot of things was happening when there was this war between AC and DC. Who will win? AC or DC? But finally, who won? AC won.
Yes.
Because it was mainly because of these two things, this transformer and induction. Because at that time, we didn't have any technology to step up or step down DC. So since this first DC station, commercial DC power station by Edison was this one, Pearl Street station, and it was at 110 volt. Even if we take 220 volts, then the current at this low voltage will be very high, and that will result into I square R losses. So this distribution system which he had proposed or he had created was very limited because of huge losses. That is why this station was decommissioned. But then, after this discovery of these transformers and induction machine, everything changed. And AC was used everywhere because of high efficiency and low losses and lower cost. And we could easily transmit power over long distances because of step up and step down of voltage and power level by using transformers. But now we can have these. Now we can even step up and step down DC. That is what we are doing in. How are we stepping up or stepping down voltage or power levels in DC? What are we using for that?
DC converters.
We can use them. So there are different types of converters. Most basic one are these three, which we know: buck boost and buck boost. And then we have higher. Yes, but then we can only provide up to 1:4 ratio. Once boost or buck 4 times. Beyond that, we have to go for the other converters. So this is done. Next question is, which of the following is one of the key features of a smart grid? So which option is correct?
B is correct.
Correct.
Pervasive control.
So we have control over almost everything, provided we have sufficient number of sensors. So in conventional power system and smart grid, main thing is this two-way communication. Then another thing, now we have generation at almost each and every voltage level. At least up to 132 kV we can have, even 220. Big solar farms are connected at this high voltage level also. And even at home, single phase or 3-phase level we can have generators, small PVs, EV is there, so all these things are there. We have sensors everywhere. In India we don't have sensors much in distribution system, but in US, Europe we do have several sensors available. In US, even just as we use prepaid mobile connections, similarly they have prepaid electricity meters.
Sir, this prepaid meter is a part of smart grid. What today we are listening is prepaid meters.
Yes, it is one step ahead in our journey to achieve fully smart grid.
Sir, prepaid meter doesn't have any communication. It is just suppose a limit. Suppose 1,000 rupees is a limit, so it will cut off whenever 1,000 meter is there. 1,000 unit of electricity is there. But it cannot communicate back. So we cannot say it is a smart meter.
Yes, it is not a smart meter, but it is a step further because right now we don't even have that. So gradually we will build upon that. So once we have these prepaid meter, they should be first aware about these things. They should get accustomed to these things. It is similar to what, suppose we were earlier having only antenna. Each house we were having normal antennas. We'll have to adjust it and do it. We don't have to pay anything. But then we came up with this cable connection. After that, DTH came. Then we have to prepay. That is also prepaid. We have to pay. Then Netflix, all these things. So slowly we are evolving. So that is also a way to educate people. Otherwise, it's directly we cannot introduce smart meters, because if we are saying two-way communication, first we should know what we have to communicate. So
Yes,
awareness
industry.
is very important.
Yeah, can I share something? So
Yes.
this we have seen in the market. I work for the solar industry. So when the net metering started for the solar system, typically for the smaller application, people did not know how the smart meters or two-way meters work. And many of people, they put solar on their rooftops, but they did not change their meter, thinking that it's okay if I don't get paid for what I'm exporting to the grid. But because they did not understand how the meter would work, it was even worse, because they had to pay for what they were exporting. So instead of reducing the bill, their total consumption that was seen on the meter had gone up. So what you are saying exactly the same thing, because if you are not aware how these meters are going to work, it is going to have the adverse effect.
Correct. So this is these prepaid meters are one step ahead. So slowly we are going to introduce more advanced things. We have to start with these things. Even industry and even the personnel who are working in discount, they also have to train them. So everything has to be gradually, the ecosystem has to be built gradually. So that is where ultimately our goal is to achieve that two-way communication, fully two-way communication, where even all the consumers, they are aware of everything. They can read what meter is showing, time of use tariff, real time pricing, all these things they can see, and they can make decisions based upon that, and they can communicate to the utility that I want to. They can change their demand pattern and all these things. They can have contract with utilities that I am willing to shift my demand, and all these things are possible. So then we have self-monitoring system. We are also going for self-healing. That is also a new addition that we are trying to develop concepts on that, how grid can self-heal itself. That is a part of this adaptive and islanding. If a part of the entire grid, the small part is creating problem, it has a generation deficit, creating, there is a fault in a particular area, then that faulty section can be isolated from the healthy one. So then that islanded part should also be able to function on its own without taking any power from outside. So it should have sufficient number of generation inside it. So that itself is a big topic that we will see in the upcoming weeks, week 6 or 7. So this was a topic to pervasive control. So conventional system has only limited control. Self-healing is also done. This is safe. So we have command and control of major assets and subsystem, which helps us in fast failure detection and quick restoration and self-healing. So this is next question. Total installed capacity of renewable energy Indian power scenario as per MNRE 2022 is. So in the lectures, the data is of 2016-17, but now the new data is available. In the upcoming slides, successive slides, you can see there are, I think you would be knowing from where can you get these data. You can visit MNRE site and Power Ministry site is there. I have provided links in the PPT. You can, whenever you want, you can go and check. So, any idea about this? What is the installed capacity of renewable energy in India?
I can guess, sir, it is D part.
Okay. Any other guesses? So everyone is thinking D is correct. Okay, so let us see whether it's correct or not. We will see the data. So these are some key figures. So this is the energy mix that we have: oil, coal, gas, diesel, hydro, renewable energy sources where we have PV, wind, and waste to biomass is also there, waste to energy. Then energy consumption in India for 2021 is this much: 1230 terawatt hour. Generation installed capacity as of June 2020, this should be 23. June 23 is 421 gigawatt. But the peak demand met is highest is 221 gigawatt this year. So can you tell why is this difference? When the peak demand met is only 221 gigawatt, why are we having installed capacities 421 gigawatt?
Losses in the transmission line.
That is only, that is not that much still. It's almost double. Any other reason?
Capacity is always higher than the demand,
Yes,
because
but why?
Yeah.
you have some outages, some maintenance activities and all.
Correct. So
Some reserve unit requires.
yes, so unforeseen events. We want to supply power even in cases of any unforeseen event, any outages, any fault is there, any generator may go out of the system. So anything can happen, any line may trip. Then we should have reserves extra. So this is to ensure resource adequacy. Because every time some of around, you can say almost 100 gigawatt would be on maintenance. So they have their scheduled maintenance. Several generators would be on their maintenance. Then
Also, does this include renewable? This generation capacity?
Yes, this is our entire total installed capacity in India. All type of resources are included in this. We will see next. This is the division of that. We have thermal still 56%. Total installed capacity is coming from thermal. Then,
So again, for renewable, typical.
Hello.
yes,
Sir, good evening, sir. Previous slide,
yes.
please go to previous slide. How the peak electricity demand deficiency is the point to, because the electrical generation capacity is more than peak demand, So in that situation, deficiency is not going to be happen,
Yeah. Yes. If you see like that, it will not happen. But actually, things are not as simple as we see. So it's market, everything is governed by market, and out of market we have these power purchase agreements also. So
No, generation capacity is available. More than power demand. I don't know why the deficiency is happening.
yeah, this is happening because at a particular time that much generator may not be available, because one reason is outage. Then in market also that much generator has to be available.
Also,
It
for
should be
example,
cleared.
for renewable, you might not have it available also,
Yes,
even though it is
solar-
installed. For example, solar will not be available at night, or wind will not be available always.
So out of this 421, as we will see, around 31, 47% is renewable. And renewable, whatever generation is there from renewable, we inject it into the grid. And if at a particular instant, if solar, suppose it was scheduled to generate 100 megawatt, but actual generation was not as 100 megawatt. Maybe there can be several reasons. Solar irradiance was less, temperature was high, so output of solar could have been less. Wind, these things are not under our control.
Okay, sir.
For each time block, the generation scheduled is fixed. But actual generation, what happens in real time may be different.
Yeah, that's why we are using unit commitment and economic dispatch problem and all.
Correct.
Anyhow, our ultimate objective is to meet out the power demand.
Correct.
We have to provide the electricity 24/7. That's why we are studying so many techniques like economic dispatch and all.
Yes.
Even the power capacity is also available, lesser than power demand. But okay, sir. Thank you.
Yeah, because
I don't know. Yeah.
even thermal generators, they have a limit on ramp up, ramp down, right? Suppose a thermal generator is running at a particular level. In next 15 minutes, it needs to generate more than its ramp up capability. It cannot do that. Then deficit may be there.
Okay, sir. Thank you.
That is one of the reasons, but there can be other reasons also. So we do have deficit right now, even after having such a huge install capacity. And it will become more difficult as we go on adding renewables. That is why we are thinking of installing storage, energy storage also. So that when renewable is not there, its output is less because it keep on fluctuating. So we can still serve the load using the storage. So this is the energy the breakup for the installed capacity. 56% is still coming from thermals, 47% is from renewables. Here hydro is not included. It's only including small hydro power plant. Hydro is considered separately in that data. So this is, if we combine this, it is this is 47%. Then we have others are nuclear 2%. This is for renewable capacity. So 54% is solar right now. So this is data for June 23. 34% is wind, 8% is biomass, and then this 4% and 1%. 4% is small hydro. Oh, there is a mistake here. This should be small hydro. This should be small hydro and this should be biomass. 8% is small hydro and 4% is biomass. So I have provided links below. You can go and check anytime. And this is electricity consumption pattern for all the utilities and non-utilities. So highest consumption, you can say 41% is by industries. Domestic also forms 27%. 18% from agriculture. You will also see what are the losses, total energy losses in India. So answer for this question is 113. So we saw here also, we see 70 is this, renewable is 129 gigawatt. This is for 23. 22 it was less. Answer is 130. 113 gigawatt. This is, I was talking about losses. Overall network losses in 2016-17, it was mentioned in the reading lecture also. Which one?
T22%.
Correct. So right now also it is less, but it has not reduced significantly. We will see what are the figures for last year. So the correct answer is this 22.7%. That is huge. Transmission losses are only 3 to 4%. The rest is other type of losses. So this is the data taken from this All India Energy Statistics General Review. Every year CEA will publish this report. So this is data for year 2021-22. For this year we will get the report next year. So these are the region-wise transmission losses. So highest is in northeastern region, and the total losses are around still 16-17. It was 22.7. Now it has reduced 2%. It is still high, 20.73% energy loss. It is quite high. So these are the highest we can see. It is in northeastern region and lowest in southern region.
So it is the lowest in southern region because they have more HVDC. Is that so?
No, even HVDC also has losses. Right?
Yeah, it will have, but then I mean that's why I'm asking.
Yeah, there are several reasons.
Why
There are several reasons for that. Even you can see transmission losses are also minimum for this southern region. So one thing depends upon this total energy losses has transmission losses plus distribution losses plus they have mentioned unaccounted losses.
That is electrical theft. Am I correct, sir?
Which one? Electrical?
Electrical theft.
I could not understand the last term. Which is electrical?
Theft.
Tough.
Yeah.
What do you mean by that?
Unknowingly, just with the help of tappings, they are consuming the electricity.
Correct. That is,
without metering, they are consuming the electricity unknowingly.
Yeah, that is a major issue, especially in the states which are having high losses. That is one of the major reasons. Distribution companies are facing. That is why discoms are not making profits. They are under huge loss. Several discoms are under huge losses. Therefore, the central government has, anytime they come up several schemes. This Uday scheme was also for them to take them out of these losses, which will discount insurance agent. For this scheme, because they are in loss. In distribution, losses are more than transmission system. Because R/X ratio is more in distribution system than transmission system. Losses are also more. That is one reason. Then, as correctly pointed out, that people are just drawing power, but they are not paying. So that is theft. That is one of the major reason in several states. So it's 22.7. And what is the 2030 target for renewable energy installed capacity? I think this everyone should know. Which one is the correct answer? 200, 400, 450, 500. No one knows? Yes. Anyone, you can make a guess. Anyone guess?
$500.
500 is correct. This is India and COP, Conference of Parties 26. At Glasgow, India gave this Panchamrits. So out of these, two targets were this: to achieve net zero by 2070 and to achieve 500 gigawatt of non-conventional resources by 2030. It's a very ambitious target. Difficult to meet this target by 2030. Because right now we have 123 gigawatt. It's 2023. Still we have 7 years. Let us see how much capacity we can add.
Still ambitious.
It will take time. Several huge solar and wind.
Along with the storage.
And storage is also planned. This CA report is there for capacity transmission planning for 2030. They have mentioned, they have identified the storage requirement for each region, for each state also. And also they are coming up with offshore wind farms. Right now we don't have, but we are planning offshore wind farms. Right now all are onshore. Offshore means they will be inside, away from the coast, inside the ocean. Because what's the reason for offshore wind farm? Why do we go for offshore wind farm? Because the wind is steady and also wind speed are higher in ocean. That is why several countries are using offshore wind farms. Denmark is even creating one island, energy island. So they will be having several offshore wind farms, storage on that island. So this is already done. IEC stands for Indian or which one is correct?
International.
Yeah, so he is correct. Then wired communication system consists of cellular, optical, fiber, satellite. Which one is
Fiber.
Objective of ancillary operation in market domain is
Provide frequencies.
yes, this is correct. We will see. This is based upon draft ancillary services regulation. So these ancillary services are the necessary services required to support the grid operation for maintaining the power quality, reliability and security of the grid. So there are three kinds of ancillary services as mentioned in this draft. One is frequency control ancillary services, then network control and system restart ancillary services. So this will require these also called flex start. And there is outage, blackout. Then we need these services. Then in frequency control there are primary, secondary and tertiary reserve ancillary services. So this primary are based upon the governor action. And secondary is based upon AGC. Third are provided by the spinning reserve or non-spinning reserve. So they are slow acting. So first of all, this governor action will come into picture. So it can respond very quickly, 2 to 5 seconds. Then if frequency is not controlled by this primary reserve, then secondary reserve services are used. This is based upon AGC signal. Automatic. What is the full form of AGC? automatic governor. Then, if it is still not arrested by the secondary reserve, tertiary reserve is used. We will see in coming weeks that energy storage can provide all these services, even these. Storage is very different element which can provide almost several types of services. It is difficult to provide by any other element. Even at all the levels, transmission, distribution, generation, all the three levels, storage can provide any kind, several types of services. Then we have network control, ancillary services, managed voltage control, power flow control. Then this is flex start. Because why do we need this system restart services? Can anyone of you tell?
Blackout. For grid fail, then we have to restart the.
Yes. So these generators, these are huge thermal or these nuclear generators. They have auxiliaries which are required to start the plant. So if the plant is shut down, from where will they get the power? So that is provided by these generators, which can act fast on their own without any requirement. These can be big diesel generators. And storage can also provide this service. So this system provide frequency support services. And which standard belongs to wide area situation awareness?
It is A.
Are you sure?
1547 IEEE. IEEE 1547.
Are you sure?
So that is for IEEE 1547 for smart grid design operation control. But for wide area situation, I don't.
It is for interconnection of DERs.
Yes.
This is generally for microgrids or at distribution level. For transmission level, we have new standard NPTEL 2800 for interconnection of DERs at transmission level. We will see in the next slide what are these different standards. So these are the different standards. So for interconnection of DERs, 1547 is there. IEEE 1547, then IEC 61580, and IEC 61400. The wide area situation awareness is this C37. For substation protection and automation is 137. And similarly for time synchronization. So, why do we need standards?
For interoperability.
That is one.
Standardization.
Simple example you can give, suppose
Equipments need to be conformed with that standards.
yeah, but why?
Maintaining the quality.
Quality is
So if the standards will not, if the equipment standard will not comply,
then control will be difficult.
Yes, that is also correct. It will be difficult because we have system is one, and if different manufacturers are manufacturing different things without any standard, so they will be using different things. They will be using different type of control, and it will be very difficult to analyze what is happening. They can have different impacts on the system. And it will be very difficult to.
In that, my submission is IEC is dominated by European Union,
Yes.
and IEEE is for the entire world. So we should concentrate on one standard rather than European standard.
Yeah. We use different type of standard for. It's not like that we are using only IEC. We use IEEE also. Even for
No, that is what I said. Now see, we have to standardize only with IEEE. IEC is focused on European Union.
Yeah, for different things we are using different standards. Even
Also, IEEE is dominated by America. The grid type of India is much similar to Europe than compared to America. That's why most of the cases we go ahead with IEC.
also because of the legacy which British they have left.
No,
with
that is
us.
right.
Yeah.
Because we were from the Commonwealth country.
Yes,
So
yeah.
that is why IEC, but now the world is IEEE is international, and US based, no problems. But still, IEEE is the bigger umbrella. What I want to say.
Yeah, that is true. We are using even IEEE standards also. We are using. If you see EV chargers, there are several standards. We are using different type of standards.
In case of what will be preference order IS, IEEE or IEC in case there is ambiguity or
No, there is no ambiguity as such. The panel, the advisory committee, they will study all these standards. They will decide that we will follow this. And in India, they will follow that particular standard only. You cannot follow any other standard for that particular.
If the IS is there, you have to follow IS. IS is typically most of the times based on IC or IEEE, but it is specific for India. So if IS is available, I think the highest priority goes to IS. If it is not available, then I think typically between IC or IEEE choose.
Yeah, so they will decide. The committee will decide. They will come up with a particular standard, and everyone will have to follow that standard in India.
Yeah.
So now, which one they are going to opt, that they will decide with due deliberation. These are important. Cyber security is time synchronization for 1547 and C37.
Just one curious question. Has India seen any cyber security attacks on grids?
I will have to check. I don't remember at the moment. I had one list of recent cyber security attacks in power systems in different countries. And, I think it was there, but I am not remembering. I have that list. Maybe next time I will share.
Okay. I mean, it's not important. Just so I was curious.
May I add one point to this?
Sure.
What the question has been? Yes, it has happened recently in India.
Okay.
In Bombay, it has happened.
Okay.
Few SLDs has been also attacked with Chinese malware. So officially it has been happened, but internally it is there. Still it is persisting. Still China malware has been there in SLD.
Okay.
It's, although we are trying to move to smart grid, we want to make everything smart, and backbone of that is communication infrastructure,
Yes.
and that is also very critical infrastructure. Very also vulnerable to cyber attacks. So we have to make it very robust against any kind of attacks. That is a very big challenge, to design a good, secure cyber physical system. This entire power grid is a cyber physical system, and its security is very important because entire grid can collapse if a wrong input is there. That is why there are several studies. For example, PMU is also one. We are using PMU for estimating the grid of the state of the grid. If someone is proofing that PMU, injecting some spurious data, distorting the data, then it will result in wrong estimation of the grid, and then subsequent decisions will also be wrong. So that can create a lot of problem. So people are working on this, how to detect these different kinds of attacks and how to overcome them. But it is still an open challenge. So next is, which of the following quantity is not measured by a smart meter measurement? So
Voltage sag. Thanks, sir.
So smart
C part.
meter, this is correct. So do you know what is voltage sag?
If compared to reference voltage is reduced lesser than the specified voltage. For example, our domestic appliances, we are using 230 volt. Instead of 230 volt, whenever we receive lesser than 230 volt, that's going to be the voltage sag. That is the situation of voltage.
Is it measured instantaneously or for a particular duration?
Yeah, depends on the duration. Again, it's classified into many categories like instantaneous voltage sag, temporary voltage sag, like that.
Correct. There is they have classified, clear classification is given based upon the number of cycles or duration. So there are several of these. Smart meter can measure these voltage, current, active power, reactive power, and then what else? You can also measure the power factor and angle. These are the different power quality issues. Here you can see temporary reduction, RMS reduction in voltage. The next is, in advanced meeting infrastructure, each smart grid communicates with which one of these?
MDMS,
What is full form of MDMS?
Meter Data Management System.
So there are two configurations mentioned. One is the meter can directly communicate with this MDMS. Second is there can be these several meters can communicate to one concentrator, which can then communicate to MDMS. This can be a concentrator.
But before that, there is
before that,
Head end system is also there before MTNS.
what is that?
Head end system. HES.
Yes, correct. That is correct. I missed that. Head end is also correct. Next is, what is the function of smart information meter?
On.
This is correct. Generation, integration, analysis. In smart grid, the distribution domain will communicate more closely with the operation domain in real time to manage which of these follow.
Is the
No, he is not correct. And C, distribution is
power flows.
correct.
B.
So, the main function of this operation domain is to check entire system is working smoothly. So, operation domain will monitor all the power flows in the entire. And the next question is, the meter concentrator is responsible for supporting communication with the meters over
A. NAN A.
correct. Full form of NAN is
Neighborhood area network.
okay. Questions are over. If you have any doubts,
Sir, my one question is, though it is not related with the, you said there is utility and power buyer, they do bidding. What type of bidding is this? Bids, you said, na, for the demand and generation there are bids.
yes.
Can you elaborate that
Yeah,
bid?
sure.
This is what first price bid, second price bid, auctions. What is that?
So they will provide. Suppose generator is there. The generator will say that generator is willing to provide 100 megawatt at this much rupees. Two. Let's say 2. Similarly, all the demands will also provide. This is generator software. Demand will also say, let's 100 megawatt at rupees 10. So actual, it becomes something like this. This is, if we stack all the generator software, and these are demand split. This is a very simple example. So in this case, this will be the, say, this is price here, x-axis, and y-axis is the quantity. So this is, we call it as market clearing price, and we call this as market clearing volume. The voice is not clear. Can you repeat? So this much volume will be cleared in the x-axis is quantity. So how much? Let's suppose this is 100 megawatt. This is another. Let's 125. So in this market, 150 megawatt is cleared. Let's say this is 2 rupees, this is 10 rupees. This service, let's say 5 rupees per kilowatt. So if this volume is acceptable to the network, then this price will be set. If it is not acceptable, then we will have to change this setting. So all the market participants, they will get the same. This entire market will be cleared at a single price. This is called uniform market clearing. There is also one more way to clear market, which is pay as bid. So in that way, what will happen if this generator is saying that I am willing to offer my 100 megawatt at 2 rupees, so that this generator will get only 2 rupees. And here, because market is cleared at 5, so this generator is making a profit of 3 rupees per kilowatt. Do you have any question, Suman?
Sir, I had a question.
Yes,
Sir, I think it is not related or related. Who is taking care of like authority or a body type for integration of all these things like smart grid, for the smart grid? Is there any
smart meter and smart grid?
Smart grid. In the smart grid itself, smart grid it is.
Yes, smart.
But like power grid is doing for inter-regional transmission, like which body is taking care of this in the future?
Actually, smart grid is a very big thing, big concept, and in that we saw 7 domains are there.
Okay.
Each domain has its own role to play.
Okay.
So even we saw operation domain. Operation domain is handled by Grid Control of India Limited in India. Then we have markets domain. So in that,
regulators.
We have power exchanges, which is this different PXIL, IEXL there. Then market management is done by again Grid Control of India Limited. This is also National Load Dispatch Center for us. Similarly, how this division, who made this division? So this was done as per Indian Electricity Act 2003. So the government has segregated the work which will be done by different entities. So they have created this power ministries there, they will make policies. Then these SERC, CERCs are there, Central Electricity Regulatory Commission. Each state has its own State Electricity Regulatory Commission. So they will make these policies on tariff. So each entity has its own role to play. So different entities perform different functions, and together they will make whatever they do will contribute in this. So right now, transmission system that we have, it is kind of smart only. Several things are automated. We can monitor everything in the VAMs by using the VAMs. So Grid Control of India Limited, they have entire control system where they can see which line what is the flow in a particular line, flow in any line is beyond its limit. They can see all these things. Whenever such thing happen, alarm is there, so they can see the alarm. Log is there, they can see what type of warnings are there. So entire system is there, which is fully automatic. and a person is there, several persons are there who are always monitoring this. So even sometimes if there is a mistake, because of their experience, they can take decision. So this is the control aspect, operation aspect of transmission system. All the generators, they also have entire system which is automatic. Whenever there is any kind of fault, there will be a trigger, there will be alarms which will tell the generator has a problem in winding. Any kind of problem may be there, so that will also be triggered. The generation transmission are not a big problem right now. One problem is protection because of renewables, which create these bidirectional power flow. That is a new thing for our power system. So that is an important aspect that several techniques are being developed for protection system, especially for the distribution system. The main point for us is right now this distribution system. Their automation is not there. Losses are also very high, and it's very difficult. In India, it's such a big country. Each distribution company can have lakhs of consumers, so it's very difficult to automate that because that will require communication infrastructure that will be very costly. It will add a huge burden on economic burden, we can say, on the distribution company. So although we want to make systems smart, but that also need huge investment and also awareness on the part of consumers. So these things are gradually developing and all the entities are working so that we can make this smart cities. This smart cities concept also was being developed keeping in mind that we have to make a smart grid. So one important aspect of smart cities is the smart distribution system. So there is one forum which is India Smart Grid Forum. It's not a government body. So they have collaboration from both industry people are also there.
Sir, your voice is not clear. Some echo is there.
Is it better now? So we have India Smart Grid Forum. They have participants from industries also, members from industry, from government also. So they are doing a job of this. So they do several types of studies how to make smart grid, Indian power system really smart. They have different types of training sessions also. They have several courses like blockchain, use of robotics and AI in power system, an electric vehicle, cyber security. So all these aspects they are considering, even integrating gas and electricity network. So they are doing.
Sir, your voice is not clear, sir. Again, there is some echo.
Is it clear now?
No, sir. It's not clear.
What's the problem?
Some echo is there.
For us, it is not much of echo. And yeah,
I think two of them nearby your places.
I think it should be fine now. Is it better now? So I was saying this India Smart Grid Forum is there in India. It's a task. India's Smart Grid task force is also there. IS, GT, and then India Smart Grid Forum. So they perform these type of studies. They are collaborating with industries and government officials so that they make certain recommendations to the government bodies to make policies which can help us develop these concepts. Especially right now they are working on these electric vehicles. How can we increase electric vehicle penetration in India and not affect our grid? These are very important things. Any other question?
Then can I have your email ID to contact?
Yeah, sure. Is there any other doubt? Are you saying something?
No, sir. No. Email ID.
Meaning of multi-energy system? Yeah, it's a good question. I will just let me write. This is my ID. I have mentioned it in the chat box. So multi-vector energy system is the one thing just I told you that ISGF is working on. Integrating this electricity and gas network. So multi-energy